Yo, what's up, guys? So, as promised, we're going to continue financial maths and where we left off in class. We spoke about the future value formula and its applications in sinking funds and investments. So, now we are moving on to the present value formula and its applications. And we know that it's popularly used with loans and stuff. So, in this case, we're going to be looking at how to calculate the balance outstanding, let's say, on a loan, right? Or just basically how much you owe the bank. All right. So how do you decide how to calculate that? First of all, you look at the information that you're given. Okay. So if you're given the total number of payments, so if that is known, all you need to do is to find the balance. All you need to do is, if you have the installments that you pay and you have the interest rate, all you need to do is to plug in the number of remaining payments. Okay, so this n over here represents number of remaining, keyword, if you can spell, remaining payments, right? So this n here, all we need to do is to discount the present value formula of the negative is always discounting. We're getting the value of the loan at a given time, right? So here all we need to do is to calculate the present value of all the remaining payments. So we know how many payments we need to cover at the end of the term, and we know where we are. So we just take the total number of payments that is required on the loan minus the total number of payments we've made, right? And that will give us this n over here, right? So n is used a lot for different values. In this case, it just represents the number of remaining payments. Okay, so using all the values that you're given, nothing has changed, then you get the balance of a loan. If you know exactly the total number of payments that you are required for that loan. So suppose you're not given the total number of payments and all you have is how many payments you've made, right? So what we do is we take the value. So this P represents the value of the loan from day zero, from the day that you got the loan, and then you accumulate it up until the time that you are at, right? And then you subtract the accumulated value of all the payments you've made towards the loan. So you notice the difference between these two formulas. This one is your present value formula, this is your future value formula. Okay, notice the difference. Okay, so this one is accumulating all the payments I've made towards this loan, including the interest, and then over here I'm accumulating the value of the loan itself, adding on interest up until the time that I'm at. So this n here, right? This n here represents number of payments made. If I can spell. So the keyword there is the number of payments made up until that point. So that's the difference between this n and that n. The red n represents remaining payments. The blue n represents number of payments made up until that point. So this one is a more intuitive way of calculating the balance outstanding, but this is a more simpler way, just one formula, or you need to plug it. All that changes from the original formula is the value of n. Okay, so now we're just going to look at an example, see how we can apply. Alright, so let's look at an example. So we're just gonna answer two questions, starting with this one, and then hopefully we'll be able to understand better how to calculate the balance of a loan, right? So in this case, Tendo raised the home loan. Alright, there's our keyword. The question is working on a loan. So we know we're working with installments, we know we're working with the loan, we know that we need a present value formula. Okay, so in our minds we already know what we're going to use. A loan of 1,500,000. So we know this is our P, our present value at the moment, at an interest rate of 11% per annum, compounded monthly. Alright, so now remember we discussed that you either have effective interest rate or nominal interest rate. So now they tell us that this interest rate that's stated, it's compounded monthly. So that's nominal interest rate. If they hadn't added this bit here, these two words, then you know that it's an effective interest rate and it's your job to convert it into nominal interest rate depending on how frequent this person pays off the loan, monthly, quarterly, semi-annually, and things like that. So now we know that our nominal interest rate is 11% compound monthly, keyword compound monthly. So she intends to pay off this loan over 20 years. Alright, so in this case, we already know something. She's going to be paying it every month over a period of 20 years. So is 20 years our N, or do we factor in the fact that this loan is compounding every month? So in this case, our N is not just the 20 years, but we take the 20 years multiplied by how many times the interest rate compounds, right? Which is in this case 12. Okay, and we have this is going to be 240. 20 times 12, 240. You can check that on your calculators. So she pays the first installment 1 month after the loan was granted. Okay, so why do they tell us that? Why do we need to know that it was paid? She started paying 1 month after, because our normal formula for the present value or the future value formula always takes into account that the first installment happens a period after the loan was granted, or a period after the investment began. Okay, if this had happened immediately, then we just add a 1 to our normal future value formula or normal present value formula. Okay, just keep that in mind. So yeah, let's get to it. So the first question says, calculate the monthly installments. Ooh, okay. So where do we start? So first of all, we start with the formula. Okay, we know that the formula we're using is the present value formula. X representing what we're looking for. Present value 1 minus 1 plus our interest rate here. We had said that it's a nominal interest rate of 11% compounded every month. Over here to the power of n, we have a negative, you know our formula, right? Negative 240. Nothing changes there because the payment happens 1 month after. Okay, important information. And then we close our bracket. Over here, we have the same interest rate that's up in there, which is divided by 12. Okay, so this is what we have. And then all we need to do is to plug this whole thing into the calculator, right? And our P in this case is 1/500,000. Okay, so the value of X that you get here, it needs to be logical. Okay, so you can't get a value of X which is so big that will cover this loan within 20 years, before the 20 years even hits. Okay, so you need to make sure when you check your value here to make sure that you put everything correctly. This one needs to make sense depending on the amount of the loan and the term that I have given to cover the loan. Okay, so now we'll look at the second question. Alright, so now that we know what the monthly installment is, we have enough information to answer more questions, right? So B is asking, calculate the outstanding balance of the loan after the 60th installment. Okay, outstanding balance, which is what we're talking about, after keyword here, the 60th installment. So remember, like we said, there are 2 ways of calculating this value. So in this case, we look at the information we're given. We know how many installments you should make at the end of the term, right? So we use the first method. So the first method requires that we find out what is the number of remaining payments. Okay, how do you find the number of remaining payments? First of all, we look at the number of payments that we need to make minus the number of payments. This is after the 60th payment, so we made a total of 60 payments minus 60 payments, right? That is going to be 180 payments left. Okay, my math is correct. You can check me on that. So now, next, what we need to do is go back to our formula. So the beauty of financial maths is we have a lot of formulas that we can use, so it's very valuable that you memorize them or at least understand them, right? Over here, we said that previously, if you remember where we started, we take, I'm just going to put in values for now, okay? I mean, variables. we take x, right, 1 plus I, and then here we put in the number of remaining payments, right? If you remember. Now let's sub in the values. Our x in this case is 15,482.83. 1 minus 1 plus 11% over 12 minus 180 divided by 11% over 12. Okay. Okay, so the second method, I challenge you just to try the second method, because in this case, we also know how many payments we've made. So all you need to do is to accumulate the loan up until the 60th installment, and then subtract the accumulated value of your payments up until the 60th payment, and compare the two. Okay, if the two are the same, then you're okay. If there's something, if the two don't correlate, then you need to check your values and the method that you use. Alright, so now we're going to look at logs and how to apply logs to find the value of payments that need to be made towards an investment or towards an